Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, last lesson of chapter 8 is 8.3.4. We're building triangles today, and this is another one of those lessons where it's going to be a little bit tricky unless you can, have tracing paper or whatnot. We're just going to do the best that we can and make this lesson work. There's a big idea that's happening within this lesson. So doing the actual constructing or building of the triangles is not the key. The key is to make sure that at the end you understand the bigger ideas. So let's just go with it and see how well this works. All right, so triangles are important shapes. They are the basic building blocks of many architectural designs and structural supports. A tripod stool will tend to be more stable than a chair with 4 legs. This is because of triangles. In lesson 8.3.3, you became familiar with the technology tool for building shapes and gained some basic information about triangles, or about angles in triangles and quadrilaterals. Today, you will do a more in-depth investigation of triangles. You will learn about when a triangle can and cannot be made, and you will discover the necessary condition to create a unique triangle. That is a triangle where no other triangle is exactly the same. All right, so first off, please copy down this triangle. It says how many parts does a triangle have that can be specified or measured, and what are these parts? And I'll give you a tip, a little hint. You've got these things right here, and you've got these things right there. So I'll just go ahead and reveal it. There's no quiz here. Let's just go ahead and say you've got a total of 6 parts in every triangle. 3 of those parts are sides. Side 1, side 2, side 3. And 3 of those parts are angles. Angle 1, angle 2, and angle 3. Okay, so all triangles have a total of 6 parts. And we're going to learn about how many parts do you need to know in a triangle before you can figure out what all the other ones are without actually being told what they are. All right, so how many different triangles do you think you can make specifying only 2 measures? Okay, so remember, you've got a total of 6 parts. And so if you only have 2 measures, maybe you have 1 side and 1 angle, or you got 2 sides, or you got 2 angles. That's what we're talking about here. And that's what it says right there. So work with a partner. Now you're just going to work on your own using the technology tool. Oh, what is the technology tool? Hold on for a second. Let me pause and pull this up. All righty. I'm wondering, I bet yesterday they added a technology tool to these lessons. I'm wondering if in this lesson from the other day, you had access to a technology tool. You did. Isn't that interesting? All right. Well, I would recommend you use the technology tool. Let me actually go back to today's lesson, which is 8.3.4. And it shows here you've got the problem number 92, triangle creation tool that you can use instead of printing off. Oh, goodness gracious. So what do? Can we just like move these guys? Oh, isn't that cool? So you can change the side lengths. And how do you change the angle measures though? I don't see how you change the, I don't know. Go ahead and play around with it if you like, or you can just watch me with what I'm doing with this. Either way, it works just fine. Go ahead and play with that and see how well it works. It says each person will attempt to build a triangle with the specified angle measures and or side lengths listed below without looking at the partner's drawing. Okay, so you're doing it on your own. So I'll do some and you do some, and we'll see how they end up comparing with each other. So for part A, we need to have one side is going to be 4.5 centimeters long, and one angle will be a 135-degree angle. And then for B, it'll be 2 angles. One will be 90 degrees, one will be 60 degrees, and then the third one will be 2 side lengths. So one where you got one side, one angle, one where you got 2 angles, one where you got 2 sides that are dictated. And I guess what we're going to do is we're going to see if we create triangles, do all of our triangles look exactly the same, or could they look different? So let's start with this one right here. I have taken it upon myself to create with this tracing paper. This is 4.5 centimeters long, and this is an angle that I've already pre-measured is should be 135 degrees or pretty close to it. I think, can we all agree that that looks like 135 degrees? All right, so what we need to do is we need to manipulate these to create a triangle. So what I might do is this. I might just go ahead and set this angle right here. And then I'm going to lock those guys in. And now I'm going to create a triangle. And I'll do this maybe in the color of red. Do it a little thinner, do it the color of red. And so we've got one side here. You've got this one is length, it's 4.5. And now we can just go ahead and combine those and form a triangle, right? Okay, so let me group these guys together. And let me label this as this is my side that is no. Red, very fine print. This is my 4.5 centimeter side. And this right here is my 135 degree angle. So I guess the question now becomes, can I create another triangle with this side and that angle that will be a different shape, an entirely different type of triangle? So let's go ahead and I'll do this one in blue now. And we've got to have this side is 4.5. We've got to have this angle that. But what if I decide to make it this long? Or what if I decide to make it really, really short? Maybe I'll do that. So we still have our side, which is, wait, is that right? Hold on for a second. Let me move these guys over. Hey, group together. Nah, it's not perfect. Let me get that looking better. Take this and move it up a little bit. That's okay. No, it's not. Let's move it down a little bit. Okay, there we go. So once again, you got the same length for that base, and you got the same angle, which is 135 degrees, but it is an entirely different triangle. So what we are determining here is that in this situation, do they look exactly the same? No, they do not. And what was it that we were supposed to compare the triangles you have built? Are there any other possible triangles that can be built using the same conditions? And the answer is yeah. We built two different ones where one side was 4.5 and one angle was 135. So now let's take a look at one with two angles. There's the 60-degree angle, and there's the 90-degree angle. So if I were to take and do something along these lines, let me try this. Wait, no, it's got to be a 90-degree angle, doesn't it? Doesn't it? So what if I do this? Stop it. If I take this guy like that, lock them together, and now we've got to, I'll do this one in, no, I want that. I'll do this one in red again. And so here is our 90-degree angle. And here's our 60-degree angle. So maybe I've got to get this guy all the way down to here. So this one's going to have to stretch out a little bit more, isn't it? Does that look all right? We're pretty close to it. No, I got to keep it out here, don't I? All right, so that is one that has been created where, let me go ahead, and I don't need this guy there anymore, I'm just in the way. All right, so we've got our 90-degree angle here, and we've got our 60-degree angle here. So can we do this again, but have it look a little bit different? What if I were to take this guy? Come on. There we go. Okay. What if I took this guy and moved it down to here? Now I'm going to take and do this one in blue. Go to there. Go to here. Stop it. Go to there. Is that perfect? No, because this guy tipped over a little bit. Let's go back to there. Group them together, and we've got our 90-degree angle still. We've got our 60-degree angle still. This angle ends up being the same. Interesting that they are similar. When we know two angles, the third one has to be the same as well, but they're not the same size. So with two angles being the same, out of the 6 parts, you do not necessarily get 2 triangles that are exactly the same. All right, now let's do side lengths. So maybe we're supposed to do triangles, right? So if I do this guy like this, and then lock them into place. Oh, did I ever verify that I got the sides correct? This is 7, and the other one, trust me, they're all right. So I'm going to get rid of this guy. And let's do this guy in red. So here's my 7. Here is my 4.5, and then you got this guy like that. I'm thinking, wait, no. You guys need to stay locked there, don't you? And this guy, stay locked. And now I can take these guys and group them together and label. This is my 4.5 centimeters, and this is my 7 centimeters. I don't know what that guy is. I could figure it out. But yeah, that's one way of doing it. But if I have to have this be a right angle there, could I decide to rotate this guy just a little bit? And now I still have my 4.5 side. Let's do this one in blue. Still got my 7. And now whatever this guy is forms a different triangle. Okay, so there's my 7, matches up. Here is my 4.5, matches up. But this third side does not match up. So once again, we've got a situation where if we only know 2 sides that are the same, that doesn't mean that the triangles are exactly the same. So discuss with your team whether or not knowing only 2 of the 6 possible measurements for any triangle is enough information to always draw exactly the same triangle. Well, we've actually just proven that knowing 2 of the 6 does not always give you exactly the same triangle. So what happens what if we go to 3 then? Oh, is this a 2-parter? Ooh, fun. How much time do we have here? Actually, you know what? I'm going to go ahead and stop this one right now, and we will do this in 2 parts. So this was a relatively quick lesson, and we'll do the second part tomorrow. All right, take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.